Hi everyone, I am Deekshita. This is the video presentation of my internship project at Emertxe, and the project title is Microwave Oven Simulation. This project demonstrates how embedded systems are used to control real-world devices such as microwave ovens. During my internship, I learned important technical and practical skills in embedded systems. Some of them are C programming, microcontroller basics and compilers, simulation using PIC16F877A, and interfacing peripherals like keypad, LCD, timers and interrupts. And project implementation, project overview, project requirements, project design and conclusion. Initially, in internship, we learned C programming. I learned topics such as data types, variables, if-else statements and loops, arrays, pointers, functions and memory management, and preprocessor directives like hash include and hash define. These concepts helps us to code. An embedded system is a computer designed to perform a specific task. It combines embedded systems. An embedded system is a computer designed to perform a specific task. It combines both hardware and software to operate it efficiently. Embedded systems are found in such devices as microwaves, washing machines and automobiles, etc. They are designed to be fast, reliable and power efficient. It shows the difference of a microprocessor and microcontroller. We here in our project uses microcontroller because it is low power consumption and low cost. This is the overview of project. The objective of this project is to simulate a microwave oven controller using PIC16F877A microcontroller. The system controls cooking operations through a matrix keypad, LCD, timer and interrupt functions, multiple cooking modes. The project is implemented using embedded C and tested in PICSIM lab. It shows the peripherals interface to a microcontroller for our project. Now, a microwave oven is commonly used in our household appliances, which is a great example of embedded systems. It is used to heat the food in quick and efficient way. This project helps demonstrate real-time control, mode selection, time management and display interfacing. It helps us for understanding how embedded systems works in our real life. It shows a microcontroller overview, view of a PICSIM lab. We have 4 modes. In it, the first mode is a micro mode, which is used for normal cooking and it operates in 900 watts power. When the key 1 is pressed in the matrix keypad, this mode is selected and we enter a time required, and if we want to clear that time, we use star symbol, and we want to proceed, we click on hash key. Initially, when we enter into micro mode, this power is displayed in LCD. Then here we have to set the time. After setting the time and when we click on enter, it starts decrementing the time, and we can stop the timer and start it by pressing key 4. Next, grill mode. This mode is used for grilling meat and bread. It is selected using key 2. When we press key 2, then we can select the time and clear it if we edit it, and if we want to proceed we click hash. This is same as micro mode after the selection of time. Next, convection mode. It allows the user to set a temperature up to 180 degrees Celsius. The oven preheats for 60 seconds before cooking begins. This is help for baking and roasting. It is selected by using key 3. Initially, when we set a temperature, it starts preheating for 60 seconds. Then after we can set the time and proceed. Start mode. This mode automatically sets cooking time to 30 seconds. It can also resume or pause the cooking. This mode is selected using key 4. If we want to increase the time to 30 seconds, we can use key 4. By this, we can make the timer to increment up to 30 seconds. These are our hardware and software requirements for our project. We use a microcontroller and a LCD display, which is 16:14 display, and a 4x4 matrix keypad, and a MPLAB ID for the simulation of our code. We in our project use Embedded C for implementing the microwave oven. The peripherals we use in our project are matrix keypad. The keypad allows user to select modes and enter cooking time. It works using a row column scanning method. A row and a column scanning method, which saves the microcontroller pins. It is a LCD display which displays mode names, timer countdown and system messages. This is a 6x2 display and it is a 6x4 display. In this we have 2 rows only, but in this we have 4 rows. It supports a 4-bit and 8-bit communication modes. Timers control the cooking duration, where interrupt service routines ensures accurate timing and smooth operation. I am going to simulate the code and show the output of my project. This is the main code where we call functions. They have source files and header files, which are used to organize the code separating function definitions from declarations. We have CLCD source file, ISR source file, main source file, and more. The source files contain the actual function implementation, variable definitions, and executable code, where header files contain declarations such as function prototypes, macro definitions, class definitions, and here we used a case statement for the selection of modes. Then these are the timers to control the simulation based on the user inputs. Matrix keypad source file and header files are used to select the inputs. Now let's run this code. We have successfully built the code. Now let's run it in PixSimLab. Now let's simulate the code in PixSimLab. PixSimLab is a real-time emulator for development boards, including PIC, Arduino, and microcontrollers. Here we can use several boards and select the microcontroller we want. So now let's load the file which was just now compiled. It initially displays a powering on microwave oven. Then here we have 4 modes: micro mode, grill mode, convection mode, and start mode. Let's now select micro mode by pressing key 1 in the matrix keypad. It displays power, which is 900 watts. Now we can select the time here. If we entered a wrong number, we can clear it by the star key. Now let's keep a 10 seconds of timer and run it by clicking on hash key. Then the fan starts running. Now if we want to pause it, we click on key 5. Then the fan stopped running. And if we want to start it again, we click on key 4. We want to stop, we can click key 6 as well. Now let's select grill mode by clicking key 2. Then we enter time. If we want to edit this, we can click this key. And if we want to proceed, we can click hash. Fan starts running. We can pause this, can start this, and stop executing this mode. So we can return to the list of modes display. If the selected time is completed after decrementing, then it displays time up and enjoy your meal. Now let's see the convection mode by clicking key 3. Here in this, we preheat the oven by entering a temperature up to 180 degrees. If we enter more than 180 degrees, it initially takes 180 itself. Now let's give 125 degrees and enter. It preheats up to 60 seconds. Then now we can enter the time required for heating our food. Let's enter 1 minute. Then it runs as same as micro mode. We can pause it, start it and stop it to return to the main screen. Then it returns to main screen after completion of time. Now let's start mode by clicking it on key 4. It initially takes 30 seconds by default, and if we want to increment the time by 30 seconds we can press key 4. By this the time increments by 30 seconds. Then we can pause or start. We can stop it by clicking on key 6. Then it returns to the main screen. We can upgrade this project by enabling it by remote control via mobile application and replacing the keypad with a graphical interface. Can use AI based time and temperature adjustment. Also energize optimization, efficient power management for reduced consumption. In conclusion, this project successfully demonstrates a microwave oven controller using embedded systems. It helps a strong knowledge in embedded C programming, microcontroller interfacing, interrupts and timers, and a real-time system design. Thank you.